So we have next speaker on stage, an experienced speaker who will speak more about serverless architecture. So please welcome Mr. Jilesh on stage.
Laracon ecosystem is so great. New people coming here, and everyone here is so happy to hype them up and make them feel better. In my opinion, we are working with one of the best ecosystem around the world, isn't it? Yeah. So before we jump into my topic, I would like to give a case study of the Netflix. Everyone of here has a Netflix account, right? I have. So back in the past, when Netflix decided to move their physical shipment business to on-demand streaming, the first challenge, like they experienced a phenomenal growth in their viewership. So the first challenge they encountered was how to handle this growth in terms of hardware and infrastructure. So the first challenge they encountered was like how to handle this phenomenal growth in terms of hardware and underlying infrastructure. So back to back, they decided to build the data centers. As soon as they complete building them, they run out of the capacity. So they have to start this entire process right from the scratch. Soon, they realize that their core competency is not building the data center, but their core competency is to delivering the video contents, streaming content. So to overcome these bottlenecks, Netflix decided to introduce cloud computing, and enhancing further their capacity, they decided to introduce serverless architecture for their on-demand streaming and encoding business. How that helped Netflix? Netflix right now is serving in more than 200 countries. They are serving to more than 250 million plus customers. And on daily basis, they are serving 150 million plus streaming hours with the help of cloud computing and serverless architecture. So here comes my topic, unleashing the power of serverless architecture. Myself, Jilesh, I am founder and CTO at Accu Cloud. My hobbies are I love to create the content, photography, love to read the book, and spend time with my family. You can find me on Twitter and LinkedIn. This is my sweet family. So most of us, like when we start, these are the three major architectures that most of us are using on daily basis. Like we start developing application with the monolith, then we go to microservice and serverless architecture. So as you go up in the graph, you will see that your focus on implementing the business logic is increasing, and at the same time, your focus on stack implementation, which is a hardware and stack part, is decreasing. So like we see like how cloud computing and serverless helped Netflix to accommodate the viewership. So I'll dive into all these three architectures and will explain you one by one and see the benefits. Monolith architecture. So this is a traditional software architecture. And it's a, like as you can see, these are the various functions of a common application, which is a database connectivity, payment, login, product management, etc. So in monolith, all these functions are a single unit of a code, which runs on a bare metal server or a traditional hardware. These functions are tightly coupled with each other. Server stack and underlying infrastructure is being handled by you. Since they are tightly coupled, there are chances of failure of any one component can impact on major part of your application. It supports a single technology stack. That means like you start developing this architecture with say Python or PHP, there are limited opportunities to introduce a new technology in your same application. Okay, the same architecture, same monolith application in terms of a microservice architecture. So as you can see, this is a modern software development model where each service is like database, login, payment, product management are loosely coupled and they are independently deployable. These services usually run on container-driven technology or virtual machines. There are limited scope of scalability, like they are better in scaling compared to the monolith, but they are not as good as the serverless. So you can vertically scale them, but horizontally scaling them is a little challenge over here. You have a flexibility to select a different technology stack for individual services. Since these services are loosely coupled from each other, failure in any one of them has a minimal impact on other part of your application. So here comes the serverless architecture. This is a cutting-edge software model. It's an event and function-driven model, which is completely focused on your business logic. Your entire business logic is written in terms of functions, which are completely decoupled from each other. Underlying infrastructure, the servers, the scaling capacity, everything is being handled by your cloud service provider. So in this architecture, you don't need to worry about the scaling part. Like you grow from 100 to 1,000, 1,000 to million visitors, no problem. Everything is being handled by your cloud service provider. So you have much more flexibility in introducing the different technology stacks. How exactly? So for example, DB access, a login, a payment, a product management. You take any of this business logic, you can use a different technology stack for each one of them. Since they are completely decoupled from each other, failure in any one of them can have a minimal impact on your entire application. For example, your login system is not working, no problem. Sign up might be completely working without any trouble because they are completely decoupled from each other. So now when you start seeing a growth, say from monolith to you go to the serverless architecture, what are the challenges that you will face? The first will be the scalability problem. When your application is small, no problem. 10 user, 10,000 user, 100,000 users, no problem. You can easily double up your stacks and can accommodate them. But when you grow beyond that, say million visitors, you will have to introduce horizontal scaling for that. What is that? You have to introduce the load balancers, you have to introduce the caching mechanism. So solving a one problem of scalability, you are introducing the other problems of a load balancer and those kind of management services. The other challenge you can face is a code maintainability. When you have a small applications, a monolith or a traditional, there are very few objects. You can easily manage them, like you don't need any object diagram, software model, it's a pretty easy to manage. But when you start seeing exponential growth, this is how your application actually looks like, hundreds of objects. So how to manage them? You need a proper object diagram or a better software documentation for that. So this can be another challenge in a traditional software architecture. The high availability issue. Traditional architectures have a lack of redundancy in terms of hardware. Like usually these kind of applications are running on a bare metal servers or a single node, something like that. So due to the lack of the redundancy, failure in any one of them can easily lead to impact your entire application. Also, everything is tightly coupled, so failure in any one of them can drag down your entire application. The another challenge, when you start seeing exponential growth, the another challenge that you will see is a cold start problem. What is that? In a smaller application with 100 customers, say 10,000 customers, 100,000 customers, no problem. Your cold start will remain in a milliseconds, easily accommodable, no issues. What happens when you grow to 1 million visitors or beyond that? Your cold start will be in the seconds. That will be a disaster for the user experience of your application. So cold start can be another problem in traditional applications. The stack performance tuning. Like traditional applications, the software stacks like PHP, JavaScript, hardware, everything needs to be managed by you. So tuning them, patching them, maintaining the operating systems, you have to take care of all these technologies. So that can be another challenge in traditional architecture. So I would like to give another interesting case studies of the Coca-Cola. So Coca-Cola decided to introduce touchless fountain product. Their main business motive was to introduce this in less than 100 days of time. For that, they have a challenge of faster coding, like they want to introduce this product in less than 100 days of time. Another challenge was to give the real-time user experience. Another challenge was like to, when they mix the ingredients and when they serve the beverages to their customers, the data pass from their actual user to the central data was large. And that everything needs to be done in a split of a second of time. So how Coca-Cola solved this issue? So Coca-Cola introduced the serverless cloud computing. With that, they were able to code their prototype on the faster basis. They were able to introduce this product in less than 100 days of time after the prototype. They were able to give a faster time to market and low latency to achieve their business objectives. So with the help of the serverless cloud computing, Coca-Cola was able to introduce this product in a record time to the market. So like we talked a lot about this architecture, but how exactly, like what is the serverless architecture? What are its characteristics and what are the major components of that? It's a hostless. So does that mean there are no hosts, no servers running beyond that? No. There are servers running, but as a developer, you don't need to worry about that. It is a part of your cloud computing company to take care of them. Scaling, it will be handled by your cloud provider. It's a stateless architecture. The functions in serverless, they are completely decoupled from each other. They don't know like what is the state of the front-end users. So basically, a statelessness is another characteristic of the serverless computing. They are elastic, they are distributed, and they are event-driven. These are the major components of a serverless architecture. The front end, which is a client interface, your front end, from where you start receiving the queries, you pass on them to the API gateways. From API gateways, you route them to the FAS, which is a function as a services provided by your cloud company. So your business logic usually runs on the FAS infrastructure, and the three components like cloud server, a security services, and backend database, which is managed by your cloud provider. Okay, so when you start seeing a growth, and when you decide to move your monolith to a serverless architecture, how will you do that? These are the major steps that you can transfer your monolith to the serverless architecture. The first is you need to decompose your monolith into the smaller functions that can run autonomously and that are independently deployable. Once you define the functions, you need to refactor them for the serverlessness. What is that? The functions are stateless. So you have to make them stateless, you have to make them scalable, you have to make them event-driven. What is event-driven? So these functions usually invokes when you trigger any event. So some API gateway changes, some database changes. So you need to need to write the events for them. When those events are fired, these functions will be invoked. The data will be passed to your front end, and actually they are displayed to the front end users. So when you complete these 3 steps, you can deploy them on your preferred cloud computing company. Okay, the challenge is when you start moving from monolith to the serverless architecture. State management of the users across the functions. As I mentioned, like functions are stateless. So the major challenge will be to maintain the state across these functions. For that, you have to write some front-end logic. So the state of the user is actually passed to those functions. For that, you can use any of these popular technologies like JSON Web Tokens, Elasticache, or orchestration services like durable functions or step functions. Another challenge will be the database connection handling. So in a serverless, when you see exponential growth, your functions will be called millions of times. So opening a database connection each time and closing them can be a bottleneck on the database side. So the most important thing will be handling the database connections. You can use the database connection pooling technology to efficiently handle those functions, those connections here. But the first advice will be you go with the serverless database or you go with the database as a services offering. So some of the popular, like you need to find out your cloud computing company. Most of them will be offering some database as a services or serverless database. So the future trends and opportunities with the serverless computing. By 2030, it is estimated to cross the USD $50 billion market size for serverless cloud computing. And by 2035, it is expected to cross USD 194 billion. So a huge opportunity for serverless computing. Latest technologies like AI and IoT are easily integratable with the serverless architecture. And serverless architecture can easily boost them to the next level. So the future of the serverless seems to be bright with its adoption in healthcare, pharma, IT, media, service, and so many other sectors. So we see a very bright futures with the serverless cloud computing. Have a question? I am available on the Twitter and LinkedIn, also available on the booth G4 over there. And thank you very much, guys, for being so excellent audience.
Thank you, Jilesh.
Yeah.
I have one question for you.
Sure.
So the question is from Twitter. Should we worry about scalability from beginning or only after application gets enough traffic?
Not right from the beginning. See, the one thing does not fit to all. So for example, in the beginning, you can go with the regular flow. But when you start seeing increase in the traffic, it is advisable to go with the serverless. Like any kind of surge in the traffic will be easily handled by the serverless.
Okay, perfect.
Yeah.
Thank you, Jilesh.
Thank you very much. Thank you.